Good morning and welcome to this Core Telecom hosted webinar by Adtran. The title is, Are You Monitoring Your Most Valuable Asset? I'm Lyle Frank. I'm National Sales Director at Core. I've been here for 13 years, and thanks to many of you, Core Telecom is celebrating our 25th anniversary this year in 2024. Before I introduce our speaker, I want to just do a couple quick logistics. You'll all be muted. If you have a question, please submit it via the question tool, and we will try to get to them as we can during the presentation. Obviously, if we don't get to all of them, we'll catch them after the material is presented and try to get to as many of those as we can. So again, please use your question tool as they come up. Don't feel like you have to hold them for the end. Core Telecom has been an Adtran partner for many years. We actually go back to our relationship with SmartRG, an acquisition by Adtran several years ago for their residential gateway technology. And more recently, you're probably aware, Adtran and ADVA merging, which is how this product line that we're going to be talking about today came to us. And we're really excited about this because I think when you survey your clients, most important to them for broadband service is obviously speed and price, but after that, it's reliability, and that's really what we're addressing today with this topic. So let me please introduce our speaker today, Abdala Kheireddine. He's been in the industry 15 years, has a PLM roles and system engineering roles prior, and currently he's in the business development group at Adtran. So without further ado, Abdala, please take it away.
All right, well, thank you, Lyle. Good morning, everyone, and thank you so much for joining us wherever you're dialing in from. I hope the spring breeze is coming your way. We have a very windy day here in Ottawa. I live in Ottawa in Canada, Ontario, but wherever you are, I hope you're having a really nice day, and thank you for the introduction, Lyle. As Lyle mentioned, I am in the business development group with Adtran, primarily working on Adtran infrastructure monitoring, which is the topic for today's webinar. The topic really, or the presentation today, will revolve around solutions that help you ensure that your infrastructure, namely your fiber and your enclosures, are monitored and assured 24/7 without impacting any of your services in the most cost-efficient way and in the simplest way to manage and operate. And so over the next hour or so, I would like to introduce to you the portfolio, the hardware, as well as the solutions. Time permitting, I would like to give you a live demo just to give you a sense of the ease of operation of the solution and the simplicity of it and the gains that you get with the solution. We'll talk about some sample use cases, and as Lyle mentioned, if you have any questions, maybe comments even, you may introduce them in the chat or wait till the end when we open the question answer session. And so with that, let's go ahead and start. So I kind of structured my presentation in the why, the what, and the how. And hopefully that will give you an idea of the product, a comprehensive idea of the solution. So why would you consider an infrastructure monitoring? Traditionally, people who have operated fiber networks, and I'm sure yourselves have operated fiber networks for a very, very long time, some of the challenges with operating fiber networks is, having a good grasp on the properties and characteristics of your fiber after you have deployed them. So having a real quality measure of your fiber that is in the field, and not having to rely on spreadsheets and doing an inventory of your fiber every once in a while and updating those spreadsheets and so on. The other element that becomes also important in the case of an outage, let's say a fiber cut, how long does it take you to actually find and locate that fiber cut? Because that translates into a lot of things. It translates into cost, it translates into operational efficiency, it translates into customer satisfaction, even customer retention, and so on. And then, fiber cuts are easy to detect because it will be very, very obvious. Fiber cuts are very easy to detect because it will be really obvious. But, wouldn't it be nice to have a tool that you can manage and monitor the performance of your fiber over time, so that hopefully you never get to that fiber cut situation, because in a lot of the time it's a signal degrade or a fiber degrade or a tension on the fiber somewhere that causes degradation and eventually leads to a fiber cut. Also important, let's say there is a fiber cut in the field and you have a technician that goes out, does the repair work. It would be nice from a central location to actually know and assess the quality of the repair work that was done on the fiber, so that again you have this comprehensive, always on visibility of the quality of your fiber. And finally, another thing that this solution will address is protection against malicious attacks. So if somebody is trying to eavesdrop on your fiber using a tap, data will continue to flow. You will not notice any outages or any dribbling errors even, because the loss is so small, but somebody at that moment is actually looking at your fiber. Okay. Now, outages, I'm sure everyone on this call has their own stories, but this is just a statistic, an average between 2019 and 2022 of the damages to buried infrastructure in North America. So in the US and Canada, annually an average of somewhere around 300,000 reported damages to infrastructure are collected. Now, almost half of those are contributed by Telecom. So 139,000 or so reported damages to buried telecom infrastructure is reported annually. This translates to somewhere close to 400 incidents a day, again, reported. And so losses and damages to buried infrastructure and fiber, they happen daily and they happen in big numbers, in large numbers. And the costs for this pile up, whether repair costs or societal costs. People who are all of a sudden cannot work for the day or cannot renew a prescription or cannot go to school and so on. And so it is an issue and a problem that needs to be addressed. It is addressed today, but I think there is a better way that we are going to pitch today. So here's actually some field insight from customers that we talked to. On the left-hand side is a tier 1 provider in the US who is very active in deploying fiber to the home, right? And so they're deploying thousands of those annually and maybe even monthly. And so what they tell us is that once they construct the fiber and deploy it, and a customer requests a service and they send a technician out to provision that service, 1 out of 4 times there is an issue on that specific fiber. So they go to a fresh install that they think that the fiber is perfect, this is brand new, we shouldn't have any issues, we should be done in a couple of hours and go home. It turns out there are issues 1 out of 4 times, and we were told that sometimes 1, 2, 3, or maybe even 4 truck rolls are required to repair that problem. And it just happens that I personally had to deal, even though I'm not in the coverage area of this provider, but my provider in my area, I was sent 5 trucks to get my fiber to the home connected. And so I know it firsthand what they're talking about. On the right-hand side is smaller tier 2s, tier 3 providers. What they tell us that up to 70% of the time when they have a reported fault in the field and they send out a technician to take care of the problem, and they think it's a fiber, they send out a technician with a handheld OTDR, they discover that actually the problem is not on the fiber, the problem is somewhere else. It's somewhere in the electronics, it's the upper layer protocols, something else other than the fiber. So between the two of them, on the right-hand side, you have a lot of, if you want, misused truck rolls or underutilized truck rolls. And then on the left-hand side, unplanned truck rolls that are costing providers a lot of money in terms of operations as well as customer satisfaction and retention. So what's the solution to all of those problems? The solution, in our opinion, is 24/7 live in-service monitoring of your infrastructure. And so wherever you have fiber, what we are proposing is, and I think you can see behind me this solution, this little box there that we call an ALM. We propose that the ALM, which is 24/7 fiber monitoring that runs in service with your data, with your traffic. You instrument this solution into your network. It sits in the background. It runs on a wavelength that will never interfere with any of your data wavelength. and 24/7 is monitoring the physical quality of your fiber. And so if there is a problem on the fiber, the ALM will detect the problem, will identify it, and so you will know for sure whether the problem is on the fiber or somewhere else. And if the problem is on the fiber, we will localize it for you. And that way you have geo coordinates to the fault location. So you collect this information, you give it to your technician, the technician goes out the first time not to find or locate the problem or diagnose the problem, rather they're going out to fix the problem the first time. And they know precisely where to go because they have all of this information almost instantaneously at their fingertips. Okay, so use cases for this solution. Anywhere you have fiber. So dark fiber is an important use case. As I mentioned, in the case of fiber to the home on the previous slide, that many times operators assume that their dark fiber is ready to go, and they're surprised when they go to the field and find that it's not ready to go when they get a service request. And so this gives you the opportunity to have an eye on the status of your fiber, so that the moment you get a request to turn up a service, you know precisely what's going on that fiber. Mobile and front backhaul. Oh, pardon me. Mobile and front backhaul is an important use case for the ALM for several reasons. Number one, obviously, you're monitoring the fiber, you're keeping a really good eye on the quality of the fiber. But also, the way we see it deployed in a lot of use cases at a lot of providers is as a demarcation device. As you know, the owners of the assets in a front and backhaul scenario are not the same. So the owners may not be the same. So the owners of the towers, for example, are not the same as the owners of the fiber plant. And so sometimes if there's any issues, any connectivity issues, there's a lot of finger pointing and a lot of time spent to figure out, where the problem is. So with this demarcation device, it's very easy to alienate the responsibilities and figure out issues when they arise. DWDM systems, really this encompasses more than DWDM systems. This is transport systems in general. So it could be a DWDM system, it might be a DWDM ring, but it could be an IP transport ring as well. It does not have to be wavelength division multiplexing, right? So it could be 100 gig IP ring or 400 gig now. Those are becoming more widespread and so on. And so these are your transport links on which a lot of your data and your customers are relying on, and so those are very important to monitor. Of course, being Adtran, PON is very dear and special to us, that you're able to monitor your PON network in a very seamless and easy fashion, considering the number of subs and endpoints that you might have. You cannot have a solution, for example, that require you to go to every single site and upgrade the hardware or even update the software or whatever. You want a solution that from the head end you can actually monitor your entire PON. And that is a technology that Adtran has pioneered, and we are the first to market with a solution that we call reflectorless PON assurance, which I will detail a little bit later on. A couple of highlights or a couple of important points to note for this solution. So the ALM, again, is 24/7 monitoring of your fiber assets. A few things about it is, number one, that it is a cross-domain solution. So whether you're monitoring an access network or an access and aggregation, metro, regional, core, it's the same solution that allows you to monitor this infrastructure across domain. You could even put it on the boundaries of your network, and in one direction monitor access, in the other direction monitor aggregation and metro, for instance. The second feature of the solution is that it is vendor agnostic, and so it really does not matter much who the end equipment is coming from. Of course, we would like it to be coming from Adtran, but even if the optical equipment at the end is not coming from Adtran, you're still able to monitor your fiber plan with this solution. And number three, it's technology agnostic. So whether you're monitoring, for instance, if we were to look at a metro ring, whether you're using for your transport native IP or you're using OTN or using DWDM. To us, we are completely agnostic to the technology. Again, we're focused on the photons and we're focused on the physical layer. So 24/7, technology agnostic, vendor agnostic, and cross-domain. Okay, so putting all of this together, what does it mean to you as a provider? What are the benefits that you reap from this solution? Number one, you've got saved truck rolls, basically making better use of your OpEx dollars, right? Whether you are saving truck rolls from going out altogether because you discover, you know what, the problem is not on the fiber, it's somewhere else, so let's focus our resources there, or optimizing the use of those truck rolls, meaning, you know, when you get an outage, you're sending the truck to fix problems and not to find problems. A direct outcome of this, obviously, is reduced downtime. Because we're able to find the problem almost instantaneously on the fiber, you are saving those 2 to 4 hours and maybe even more at the beginning of, you know, finding the technician, assigning the technician, giving them the handheld OTDR. They go and drive by the fiber, especially if the fiber is a long span, you know, 100, 150 kilometers, then they're taking a very long time to try and find where the problem is. And so we save you immediately at least 2 to 4 hours of downtime. So your mean time to repair greatly improves. And thirdly, you know, if you have customers in your deploy base who require higher services or have critical services, you may be able to offer them higher availability now that you're actually monitoring the fiber and you have a better grip on what's going on your fiber. So now you're able to offer better SLAs and improve repair times to your customers. Okay, so maybe, Lyle, this is a good point to take a quick pause and see if there's any comments or questions, and then we continue. How does it all work?
So, Abdala, there was a question submitted actually prior to the event, and it was relating to particularly the PON networks. How agnostic is the ALM system in terms of, obviously it would be compatible with Adtran's, you know, TA5000 SDX networks, but what about, you know, Calix, Nokia, Dasan Zone, and some of the others in the industry? Is it completely compatible with those?
We are 100% compatible with all PON vendors. You know, when I say vendor agnostic, we are as agnostic as it gets. And in fact, when we get to the demo, I will show you that when I detect a fiber break or a disconnection of an ONT, that my ONT is in fact powered off. And so the ALM doesn't have any communication with the electronics of the end devices. We're completely working on the fiber layer, and we're detecting faults on the fiber layer. Now, that being said, and I will talk about it a little bit later, there are advantages if you are an Adtran customer, right? But I will talk to that when we get. I'll talk about that when we get to that section.
And one other thing before you move on, I have posted in the chat. If you look at, I think what's on the top right of my screen, you kind of see a bubble, and that's the chat function. There's a couple of notices there about slides and links being sent for this to all the attendees, and some contact email if you have some follow-up for this. So, and again, you'll see a bubble with a question mark in the top right, which is the tool to submit questions, and obviously we welcome those.
All right, thank you, Lyle. Okay, so let's continue then. Let's press on. So how does it all work? All right, so the family of products. Let's start at the bottom row of the slide. So the ALM is our advanced link monitor. This is the tool that's monitoring your fiber 24/7. We have two variants of those that monitor 16 and 64 fibers concurrently. Now, depending on how many fibers you would like to monitor, if you need more fibers than this, you have the options to add more ALMs or to use the next product, which is port extenders. So ALM is the one that does the monitoring. If you need access to more fibers, we have port extenders. We also have a family of passive sensors that monitor for intrusion and open close of all of your enclosures, as well as moisture and flooding. The portfolio is monitored and managed using two solutions, one that resides locally on the ALM, and one that is a typical or is a general network management system that also encompasses GIS functionality. In the next few slides, I'm going to delve into a bit more details of all of those solutions. So let's start with the ALM. As mentioned, the ALM, we have two densities of the box, so a 16 port and a 64 port. Both boxes come in AC and DC versions. Both boxes are 1 RU high, one is half RU wide, and the other is a full RU wide. Okay. The basic principle of operation is however many ports you have provision and monitoring fibers, the system scans through them one at a time, so round robin kind of scanning, looking for defects on those fibers. Depending on the use case, it takes typically 2 to 5 seconds to scan through a port to do a quick integrity check. If there's any issue on the fiber, we pause and we will do a full fault analysis of what's going on that fiber. So if, for example, you're monitoring 16 fibers using the 16-port ALM, you're looking at a cycle time about 90 seconds or less. Okay. Some physical parameters of the box. So the box is very efficient in terms of power consumption at less than 15 watts per box. Right? If you compare that to an incandescent light bulb, it's less than a quarter of an incandescent light bulb. So very, very efficient in terms of power consumption. Also, the shelf itself does not have any fans. So it's a fanless design, and it does not have any moving parts in it, which makes the MTBF value, the mean time before failure, extremely, extremely high, especially for DC-based versions. You're looking at 50 years or even more. So those boxes are as set and forget as they get, right? The box themselves are, they have some basic GIS functionality on the box itself, but also we have an offering to give you full GIS functionality in a full-fledged server kind of architecture. Okay. The port extenders. So if you need access to more ports, more fibers to be monitored at a given site, again, you can either add extra additional ALMs or you use those port extenders. So we have two variants or two flavors of those port extenders. There is a 96 port version, and that is LC port based. And we have a 392 port version that is MPO port based. So you mix and match those with either ALM to give you different densities. In this scenario here that we're looking at, the top one seems to be a popular one ALM 64 and one 96 port extender. This gives you access to a total of 158 ports in 2RU. Now, if you need more, you go and use perhaps the MPO port extender. This gives you a total of 392 ports per 1RU, right? But there is no restriction, to use either extender with either ALM. Okay. So let's take a look then, how would you commission this into your network? Because I think it's extremely important in our environment that the box is easy to operate and easy to understand, considering skilled labor and the availability of skilled labor and so on. But even in the long run, to operate this box, it needs to be also simple, because you should be focused on monitoring and troubleshooting your network and not worried about the box doing the monitoring. And so the way that you would instrument it into your network is, let's say you have here in this example a simple point-to-point link, and you want to introduce ALM into it. We use a device that we call a coupler, and this coupler is nothing but a passive filter that combines the 1650 wavelength coming from the ALM with whatever wavelength is coming from your data source, right? So if this were to be, for instance, a DWDM network, somewhere around the 1528 to 1563 would be coming in on this port. And then the 1650 wavelength would come in on the OTDR port on the coupler. And then on the network side, you will have a composite of an OTDR plus data going downstream. Okay. So this bottom half of the picture is showing an active fiber link monitoring, right? That's why we're combining it with the data. On the remote end, we have a demarcation reflector. Now, the demarcation reflector's sole purpose in life is to send back the 1650 wavelength towards the ALM and let everything else through towards the end equipment. The demarcation reflector is not strictly required, but in point-to-point applications, it makes life and calculations a lot easier and a lot faster. That's why we recommend it. In PON, as you will see, we drop this requirement. Now, if you have a dark fiber application, you're just monitoring dark fiber, there is no need for this WDM coupler. You can go straight from the port to the demarcation reflector at the end of your net, at the end of your link. Okay. The good news here is that both the coupler and the demarcation reflector are passive devices, and so you do not need to worry about power and grounding and so on. And depending on how many fibers you are monitoring, you have options with the choice of your WDM coupler. If, for instance, you're monitoring a few fibers, you can use a Y cable to achieve this coupling function. If your fiber count grows, Y cables may become a little bit messy, and then we recommend that you use a chassis-based solution. In this case, we have 8 ports, 16 ports, and 32 ports to do the coupling function. The demarcation reflector is one of the most easiest functions to install in your network because it simply is just an attenuator form factor kind of device that you would plug into your end equipment. Okay. Now, once you've provisioned everything, the hardware is ready to go. You log into your box, and basically you take what we call a fingerprint. The fingerprint is a reference measurement of your birth date of the network, right? Or the birth date of the start of monitoring. So if I stick with this point-to-point application and, for example, say that I have a couple of events on the fiber, perhaps a splice box, a patch panel somewhere, then the fingerprint would probably look like something like this. You've got a reflected event at this point at distance x1 and a reflected event at distance x2. And finally, the end of the fiber at 25 kilometers. This major reflective event here is contributed by the demarcation reflector that you see at the far end. Okay, and so now the system sits in the background, reads network information, and if there's any anomaly, it compares it to this one. So, for example, if we experience a fiber cut at at location 2, if this is a patch panel, for instance, somebody is doing some work there, and by mistake they knock off your connector. So then you have a fiber cut at this location. The system will stop pausing the monitored fibers, will do a fresh full fault analysis, will take a detailed OTDR, the one that you see in the red trace, and then will superimpose it on the reference measurement. So you know exactly the nature of the event of the fault that happened. You know exactly where it is. The system will raise alarms, will log events, and will send you an email notification with all of those details. So we'll send you an email notification with the alarm details. We'll also include in the email notification an OTDR trace, and we'll include the map geo coordinates if provisioned to this site. So now your technician who is going out has all the details that they need to go and fix the problem. Okay. The passive sensors, on the other hand, those are pretty basic devices, but they have one powerful advantage, attached to them: the fact that they are not powered, that they're completely passive. And so those devices you would install in your enclosures, whether they're cabinet doors or CO doors or maintenance folds, they are not powered, as I mentioned, so you don't have to worry about replacing batteries, as would be the case in the case of IoT devices, and you wouldn't be concerned or worried about hacking or jamming or any of that, right? Simple devices, an in and an out, and a latch, right? If the door is closed, this latch patches the fiber inside, and you get an event on the trace. If the door is left open, this latch is released, and the event disappears, and you get a notification. And so this is a cabinet door sensor. This is a maintenance hold sensor, which operates on the same basic principle as the cabinet one, but it's ruggedized for the application. And then we have a moisture sensor that detects for basically moisture in your enclosures in case there's flooding or anything like that. So how it works is, here's an example. Let's say you must dedicate a fiber for this monitoring scheme. So if you have a dedicated fiber and monitoring N devices on it, on the trace, you will see n reflective events contributed by each one of those enclosures. If, let's say, somebody breaks into an enclosure or a technician leaves at the end of the day and forgets to close the door, then what happens is your trace will look like this. And if the event for that respective door will go missing, you'll get an alarm and you'll get an email notification of what had just happened. And so, really simple in terms of operation. Okay, maybe another good point to pause before we get into automation and management, Lyle. Let's see if there's any questions in the group.
Yeah, just a kind of a perspective, Abdala, from now that you've seen some of the components involved. Core Telecom has worked with suppliers in the optical transport space, and maybe some of you have looked at that, and pretty much all of them have either a blade for their system that does fiber monitoring, OTDR kind of functionality, or maybe they have a standalone blade that they manage with their system. And what stands out about this solution, obviously it goes beyond the transport application and does PON, so it has the port density you need to monitor PON networks. But not only that, the cost point is designed to be affordable for PON networks as well. And I think you'll find that if you've looked at costs on these standalone OTDRs, you're going to find this significantly less per port than what you've seen before. So at least from my perspective, that's what I've seen.
Agreed. Yeah.
That's all I have.
Okay, no problem. All right, sounds good. So let's keep going then. So that was the hardware portfolio. Let's talk about management a little bit. In addition to what Lyle was saying, so this box management-wise, out of the box, you will get an embedded GUI on the ALM itself that gives you full access to monitoring and provisioning of the solution, right? And this is included with the box. No extra licenses required, no extra setups or settings required. You don't need an external server and firewalls and all of that. So that is included and packaged with the solution and gives you access to all of the functionality of the solution. Now, if you have your own systems already and you want to integrate with them, we also give you some native interfaces in the form of CLI, SNMP, NetConf, right? And the one other main advantage of this solution is we give you basic GIS functionality. Again, this is embedded on the box. You do not need a separate GIS server. And what this functionality does is that, if you're monitoring a specific fiber, you can draw in some other software, a KMN or KMZ file, import it to the ALM and associate it with that port. And now you're able to actually give it some context, that fiber that you're monitoring, where it traverses and what it looks like. And if there's an outage, the ALM will send you an email with geo coordinates to the fault location. This is a nodal-based manager. In other words, if you're monitoring N systems, you need to have N tabs open or N browsers open to look at those boxes. Now, if your deployment base grows and you're monitoring 10 or 20 or more of those ALMs, perhaps a network management system-based solution is more appropriate. So you get a single pane of glass for alarms and inventory and FCAPs and so on. And with that, we have a solution called the Ensemble Network Controller in tandem with an Ensemble Fiber Director. So the ENC does the typical NMS functions, and the EFD gives you GIS functionality. Here, more advanced, obviously, in terms of drawing routes, cables, ducts, buildings, access points, etc. If you happen to have your own GIS deployed, we also give you interfaces that integrate with this GIS. Okay. So that's that. Let's talk about use cases now. We'll start with a transport use case, and then we will look at the PON use case. All right. So transport use case. I'm showing here in this example a 5-node network. So this network could be a DWDM network or a single 1550 wavelength running whatever data rate you are using, right? Or even a DWDM today, nowadays, ZR is becoming very prevalent. And so it could be based on ZR optics as well. Now, the first thing that comes to one's mind is that if I'm going to monitor the fibers in my network, then I will need an ALM at each one of those sites. And that is possible for maximum flexibility, but there are ways to optimize, meaning you don't need to put an ALM at every site. The reasons for that is that the ALM, for example, allows you to monitor your fiber in a co-propagating and a counter-propagating fashion. So, for example, on the span between sites 1 and 2, you can actually monitor both fibers from site A. That way you save the trouble of having to deploy an ALM in site 2. Also, the dynamic range of the ALM is about 40 dB, 41 dB or so. And so if, for example, the total loss on the fiber between sites 1 and 3 falls below that, you can also monitor those two fibers here between 2 and 3 from 1. Right? So all of a sudden, using those two features, the ALM gives you the ability to monitor this entire top half of the ring from a single site, cost optimizing where you deploy your ALMs. Okay? So that's one. PON, I think a lot of people are on the call are waiting to hear about PON. All right. So you will hear this term from us, deep PON assurance. Deep PON assurance. What is deep PON assurance? This is an innovative technology that Adtran is the first to market with it, that gives you the ability to monitor your entire PON from a central location without having to do any upgrades to your existing ONTs or existing end customers. This is a reflectorless design. If you recall earlier on in the presentation, we mentioned that we need reflectors at the end devices. Here, with this design, we actually do away with the reflector. So it's completely reflectorless and gives you 24/7 monitoring of the PON network. It supports all PON generations. And the main advantage of it is it gives you the ability to detect if there is any trouble on any of the customers, whether the problem is on the fiber or the end equipment. And that is done strictly by looking at the physical layer, not by using information at the upper layers and trying to deduce from them that the fiber is problematic or not, right? And so the ability to do this in a reflectorless fashion and using a single port of ALM for a complete PON, it really greatly reduces the cost of monitoring all the way to the end customer. If your customer, for example, if you are deploying fresh fiber to the home, the cost of monitoring the PON because of this port becomes almost immaterial compared to how much money is spent to bring the fiber to those customers. And as I will illustrate in a little bit. Okay. So as you know, maybe just reiterating here that the ALM runs at 1650 nanometers, which happens to be completely outside of all of the PON wavelength. So what this means is that there is no need to take any network offline. There's no need to do any adjustments to your network to get full management of the entire PON. And so the end result is the following. Here I'm illustrating a sample PON network with 2-level splitting, maybe 1/4 followed by 1/32, or 1/2 followed by 1/32, or vice versa even. And so in this scenario, what you will need is just an ALM to be co-located with your OLT, an additional WDM coupler over here. You take your ALM port, you insert it or you connect it to the OTDR port, you take your OLT port and connect it to the data port, and that is all that is required to manage your PON. You simply walk away. No site visit is required to the ONTs. No hardware or software upgrades are required. From this location, now you have the ability to monitor 128 ports altogether. Okay. Maybe you go, actually, you know what, let me cover a couple more slides and then we'll go from there. All right, so let me quickly talk about price because I think there was some pricing teasers in the email. So how much does this cost, right? The cost is pretty inexpensive, as I mentioned, right? So if this solution saves you 1 or 2 truck rolls, that is equivalent to the cost of a port. Actually, 2 truck rolls would probably be more expensive than the cost of a port. So if you save 1 to 2 truck rolls over the lifetime of this solution, then it will have paid by itself probably very, very early on, and then you enjoy the benefits for the rest of the life of the product. In terms of costs, there are no software or hardware licenses included with the ALM. So the hardware box that you're looking at, as well as the software that runs on the box, as well as the software that's used to manage the box, are completely included with the solution. No perpetual and no annual licenses whatsoever. Okay. In terms of total cost of ownership, as mentioned early on, the power consumption is extremely, extremely low, and the mean time before failure is very high. All of this combined translates into a product that's been shipping since 2016 and that has deployed over 5,000 units in the field. Customers include Tier 1 providers, Tier 2s, Tier 3s, enterprises, utilities. Any customer that has fiber, we have deployed ALM in those kind of environments. Okay, and so to conclude, and then I will perhaps give you a quick sneak peek of the hardware and the software to manage the box. What we've been talking about here, 24/7 in-service fiber monitoring, real-time detection of faults and issues on your fiber. Also helps you monitor your facilities if you're monitoring doors and enclosures. Works with any network, works with any vendor equipment. Deep PON assurance, innovative solution from Adtran to monitor your PON network without reflectors at the end. Identifies basically fiber faults versus electronic faults on the ONTs. And finally, extremely easy to deploy and operate. Maybe another pause line before I switch gears and go to show a live demo of the solution.
It's just another quick comment. Again, if you have questions, please submit them. But I think one of the things we've seen with talking with some of our clients about this, a PON network, the typical spec is 20 kilometers, but many of our rural clients are using lower split ratios and higher powered optics to go 30 kilometers and beyond. So even though you may have the people to cover that, just from a time perspective, being able to locate that potential trouble and with that long of a loop can save you a lot of time and effort, and obviously make your customer happier faster. So that's all I have. Abdala, back to you.
All right, sounds really good. Perfect, thank you. Well, I switched cameras. I hope you can still see. You can see my my home setup over here. Lyle, maybe a thumbs up, thumbs down. Can you see my home setup, just to be sure?
We do. We see a tabletop with a ALM device and looks like some fiber spooled.
Okay, awesome, perfect. All right, so what you're looking at over here is an ALM 16, in fact, a smaller version of the box. You're looking at the AC version of it. I have, at the moment, two ports provision that are monitoring 2 different use cases. So on port number 3, I'm monitoring a dark fiber, and on port number 11, I'm monitoring a PON. And that actually brings to mind another point, is that the 16 ports are completely independently provisionable. So you can be monitoring, as you see here, dark fiber on one, PON on another, transport on a third, backhaul on a fourth. There is no relationship between any of them. And there is no additional licenses for maybe more advanced use cases. So all use cases are supported, and there are no provisioning rules in terms of which port can be doing that. Okay. So here, port number 3, for example, for me, comes to a 5-kilometer fiber spool over here. And then out of the 5-kilometer fiber spool, it comes to a 500-meter fiber spool. And then eventually at the end of the fiber spool, I have this demarcation reflector over here that, as mentioned, sends back a 1650 wave back. So this is the dark fiber port. Now on the port number 11, I'm monitoring a PON. The PON goes to a 10-kilometer fiber spool, followed by a 1x32 splitter. And then at the end of the splitter, I have 4 ONTs. So 1, 2, 3, 4. Okay, so this is the lab setup. Now let's go ahead and take a look how it looks like in the GUI. So the GUI, basically, you open a web browser and point your IP address to the IP, or point your browser to the IP address of the box. You're presented with a login screen. You just log in with the credentials, with the appropriate user credentials, and log in. And now this is the view that you get. So again, this sits on the box. There's no need to provision a different server for management, whether on-prem, off-prem, whatever. This is in the box. As long as you have IP connectivity, you have access to this. You log in, you are presented with 5 top-level menus over here: configure for system configuration, maintain for port configuration, alarm and monitor, and logs, basically for administration on the box, conducting alarms and PMs and so on. So here is a high-level view of what's going on. I have 2 ports provisioned. Port number 3, which I call downtown ring. This is a point-to-point with reflector. The end position is about 5,600 meters. And the last time we checked this port was less than a minute ago. Port number 11, named Pawn Morgan's Grant, is a pawn network. The endpoint is about 11,000 meters away. Last time we checked it was a minute ago, and 4 out of my 4 ONTs that are monitored are reporting healthy. Now, if you go into the maintain menu and look at port number 3 specifically, right? So I'm going to go to port number 3. Here you've got a set of submenus. Port details is administration information, with one thing to point out: this priority configuration. So the priority configuration is used in cases where, let's say, you're monitoring at a specific site or location 64 fibers, right? And because not all fibers are treated equal, some of them might be more important and more critical to keep an eye on more often than others. So we give them a higher priority. And what this does, it makes sure that those ports are monitored more often than the normal priority, so that you're not waiting for a full cycle time to come back to that very important port. Okay. Now, if I were to look at the fingerprint, which is the essence of how the system works, you can see here that I have an OTDR trace that I saved as the fingerprint for that port. At 5,000 meters, that's where the 2 fiber spools connect. I have an event. And at 5,500 meters, that's where my demarcation reflector is connected. I have a major reflective event to indicate the end of the fiber. This information is also provided in tabular format, so you can see that my loss on the fiber is 1.6 dB, fiber length is 5,585 meters, latency is 27 microseconds, and other details. Now, as mentioned also earlier, I'm making use here of the basic GIS functionality on the box. I have drawn a route of downtown Ottawa in Google Earth, imported the KML file, and associated it to port number 3. So now I can click on Show Map, and I see the route of the fiber on the in real life on Google Maps, right? So that now it's meaningful for me when I have an OTDR reading. I'm not just looking at the distance, but I'm actually looking at a location. And so I'm going to just do a couple of quick, fault scenarios just to show you how the system reacts to real-world applications. So what I'm going to do is I'm going to pull the fiber right here at the connection between the 5 kilometer and the 500 meter fiber space. Go ahead and do that. Let's put the cap on. Okay. So now, while still looking at the GUI over here, we expect to see an alarm pop up on port number 3. It hasn't popped up yet because most likely the system is at this moment in this cycle is monitoring port number 11. And I can tell that by those double arrows on the port. So at this moment, when I pull the fiber, the system is monitoring port number 11. That's why I didn't see the alarm yet. The moment we switch to monitoring port number 3, I will see an alarm, and then the system will go and do a fault analysis of what's going on. If you can still see the ALM behind me, now I can see a red LED. Now it detected the loss, and the alarm has been raised that in downtown ring we have a link loss high scenario. If I click on more, now the system basically paused monitoring everything else and doing a full fault analysis of what's going on this fiber. So in a moment, you will see that I have a new trace overlaid over my fingerprint, and I get all the information that is pertinent to this fault event. Here we go. So you can see right now that this red trace is the new trace or the fault analysis. I have a fiber cut at 5,000 meters, and I cannot see the end of the fiber because now I do not see the demarcation reflector anymore. So I know this is the profile of a fiber cut. You can see this information in tabular format as well. So 100 dB broken fiber, this is the location. I can click on show map, and now you can see exactly, my map, my route went red, and I have a location for the fault. Okay. In a few moments as well, I will receive an email notification with all of this information, with an OTDR trace, with a link to the geo coordinates location of the fault as well. Once it pops up, I'll bring it back on the screen. Okay. So I think this is the biggest value of this box, is that this information is collected in the background, and you're not reacting to a customer calling that there's an outage and so on. This information is readily available for you as soon as an outage happens. Right? So I will bring, so this is the email notification that you would get, all of the details of the alarm. You've got the OTDR trace at top, and you have the link to the map location as well, where the fault has just occurred. Okay, I'm going to go ahead and replace the fiber. Then once the alarm clears, I'm going to go and basically generate a signal degrade. Because more often than not, as mentioned in the introduction of the call, that these troubles on the fiber are really accumulating over time, right? So there is some tension on the fiber, some rodents chewing on the fiber, whatever it is. And so for the longest time, data will continue to flow. There is degradation on the fiber, but nobody notices that degradation. And this solution also will detect for that. And so if I go back to maintain, I go to port number 3, I go to thresholds. Here is the place where you set thresholds on your fiber. So for example, if you remember, my loss on this fiber was 1.6 dB. We are telling it that the link budget is 7 dB. However, if we hit 5 dB, give me a warning. And also, if I have fast changes of 1 dB in a period of 5 minutes, I also want an alarm, right? So this is kind of the progressive alarming of events on the fiber. Again, keeping an eye on the quality of the fiber, not necessarily only the outages on the fiber. So let me go back here and look at the fingerprint. And now this time, make sure my camera is still on. And now this time I'm going to go on this fiber, and instead of creating a cut, I'm just going to do a signal degrade event by wrapping a fiber on the pen. I wish I had a variable optical attenuator, but this is a home lab at the end of the day, so we have to improvise a little bit.
You'll have to put that in your budget for this year, Abdala.
That's right. So again, at the moment, the system is scanning port number 11. Once it goes back to port number 3, we should be able to see the alarm getting raised. Okay, now looking at port 3. And hopefully I didn't pinch it too much that I create a fiber cut. I actually show a degrade. So there we go. Oh, good, perfect. So I know it's not a fiber cut because the system is now reporting 10.7 dB. But to validate that, I can click on more. Oops, I'm using the mouse with my left hand now. There we go. So you see here precisely what happened. We have an event at 5,000 meters. I still see the end of the fiber. I can still see the reflection over here from the demarcation reflector, but I do see an 11 dB of loss, additional loss between those two spans, right? So this again monitors for degradation on the fiber. The same information is available on the map and via email notifications. So we have a couple more minutes, and so I really want to show you the pond very quickly. Now, if we go to maintain and I go to port number 11, and I go to fingerprint, zoom in here. So all of these ONTs have reflections on them, but they're extremely slow or extremely small. And that is the innovation with our deep pond assurance, that the ability to detect for those reflections without reflectors. And so if I draw your attention to this ONT, for example, over here, it is completely not powered. I do not have any demarcation reflector on the port. However, I can still detect it. So here in this trace, for example, those 4 peaks are my 4 ONTs. And so if anything happens to any of those ONTs, even when they're not powered, fiber connection-wise, I will have an event indicating that my ONT has gone because of a fiber event. So to do that, I'm just going to pull the fiber out of this ONT, and then I will illustrate, what will happen, how the system will react. While the system is actually discovering this loss, if there's any more questions, since we only have a couple more minutes or comments, we can address them.
Sure. One comment: if you've got clients, another service provider like a mobile provider with a cell site that you're delivering service for, or an enterprise client, you've certainly got an SLA probably associated with that, and this is a way to certainly enhance that and ensure that, because I think the alternative is if you'd have to take a handheld OTDR, dispatch the site, assuming you got a loss of signal or some kind of an indicator from your electronics, and you may have to dispatch, and you hope that person knows how to use the OTDR, and so you've got time delays with that. Whereas here you can see that just in less than a minute, you're able to locate the fault and dispatch someone to the right place right away.
More or less real time, right? So, it's not easy. The field work with handheld OTDRs and shooting OTDRs, disconnecting the fiber from the remote end to run an OTDR, it really is a lot of work and it takes a lot of time, right? So this is almost real time. And so here, as you can see, I pulled this ONT out. And so I have now on the new trace, on the fault analysis trace, this peak has gone missing. So I know I do not see my ONT because I have a fiber connection, even though, again, there is no communication at the protocol layer between the ALM and the ONT, right? And so this is, in a nutshell, how the system works. I'm going to address the question that was asked in the beginning. Is there any difference when we're dealing with Adtran ONTs versus others? There is none. As you can see, these devices are not monitored, so we can monitor any vendor devices the same way. However, in a future release, we're working on a feature called DPA sync, where the ALM and the OLT will be talking. And now we are going to be able to associate these peaks of the ONTs with actual real customers and customer information. And so that when the ALM reports an outage on the fiber, the system is notified who the customer that is impacted. And so the provider will be able to actually go and do the repair on the fiber even before the customer notices perhaps that there's an issue. And the repair can be done without even coordinating with the customer, without setting appointments and all of that. So that is a feature called DPA sync that is coming. And the last thing I will conclude with, also we're integrating the management of this solution into Mosaic 1. And so we should be seeing the first iterations later this year. I thank you so much for your time. I appreciate it. I apologize, I'm a minute over. I hope you find it informative and useful. And if there's any questions post-webinar, you can either reach out to Lyle or find me on LinkedIn or somewhere and we can chat.
Thank you, Abdala. Yes, we're at the bottom of the hour. And had reached the end of our time, but I wanted to thank all of you for joining us and spending time with us today. I hope it was informative. On the chat, you'll see our general email box. If you've got further interest, want more information, or have questions, please reach out to your core telecom regional person or inside person. And if you don't know who that is, the general mailbox will get to someone who can help you. Last, I'd like to thank Abdala and the Adtran team for an excellent presentation and demonstration. Those are often difficult to do live, but you saw it here how simple this was to operate and effective. So excellent demo, and we hope to see some or all of you on our next Core Telecom event. So with that, we'll end the recording, and you'll get copies of the slides and a link to the recording if you're registered for the event. Thank you all again.
Thank you so much.